Hi guys, my name is Dylan. I'm math student currently. I'm sitting for my A levels next year, and I'm a further math student. I decided to do some recap on some O level topics, the basics of stuff, so that I myself can refer to these recaps if I ever get lost, or if you guys want to update or whatever. Yeah, you can last minute study on these as well. It's fine. So I'm gonna be going through some basics, the laws of indices and surds, as well as like rationalization, right? Rationalization, can't spell. Yeah, going through this too with some example questions taken from Anglican High School, the 2018 prelim. So let's start. I think of there are a few laws to mention. Let's see. Oh, sorry. And six, right? So I would say the first law would be simple addition law. So yeah, equal to, these are some theorems, I would say. Yeah, some examples would be like 2 powers 2 square times 2 cube equal to 2 plus 3, for instance. Pretty self-explanatory. If you want, I can make proof videos for this as well. It's fine. a power a power m bracket n equal to a power m times n. Yeah, multiply it. Given like for instance 2 square cube go to 2 power 6, for instance. Yeah, so like third would be a power m divided by a power n equal to a power m minus n. Yeah, so like 2 cube divided by 2 square equal to 2 power 1. Yeah. Uh Final stuff. A b power n equals to a power n b power n. Same holds true for a over b power n equal to a power n over b power n. Yeah. Yeah. I think one more thing for this. So a side note would be that um 1 over a power m equal to a negative m. You'll find out why later. I think you can understand it quite well after the sixth theorem. But this one would be for square root. So square root n power a power m equal to a power m over n. So like square root of 3 power 2 equal to, or 3 2 over 2. Wait, okay, wait, bad example. I think I'll use more like 3, for instance. 3 cube over 2. Yeah, like another way of writing, I guess. And lastly, a power 0 equal to, well, 1. So you can really see the connection here, right? Well, if you can't, it's okay. Think of it like a power 0 divided by a power m. So equal to a negative a 0 minus m, and also equals to 1 over a m. Now you can see it's fairly simple. Yeah, I won't dwell on this too much. I would like to focus more on the example questions, but we still got a bit to go through, I guess. Not really. Hope I don't scratch the line. Yeah. So like, uh, some things to take note. For search, right? A. Let's say A can be equal to B times C, right? This can be expressed as square root B and n roots times n root C. And express it like such. So like for instance, let's say, oh yeah, sure, square 8, right? This can be equal to square root 4 times 2 equal to square root 2 times square root 4, which equals to, well, 2 square root 2. Yeah, quite simple stuff. You can also treat it like an, how to say, more of like an algebraic term, where the square root is like equal to x, for instance, and you can do, pretty much what you can do with most algebra. So I won't dwell on that too much. Anyway, there's one more thing, which is rationalization. So let's look at it. Let's take A over B plus square root C. Plus square root C. Yeah. Now this will obviously lead to A over B plus C, or square root C. Still, you don't know what to do, right? But there's an invisible times 1, because it's the same thing. But one can do with the 1 because 1 equal to A over A, right? Or like n over n, right? Where n is a number, any number. You could do something like B plus square root C times B minus square root C. Yeah. Rationalization, you want to get rid of the square root term at the bottom. You want to bring it to the top here. That's sort of what rationalization is. That's why you do this kind of thing. You multiply the conjugate of this. So like this plus sign, now here it becomes a minus sign. Don't get careless on it. This is because plus a b minus a square equal to a square minus b square. Yeah, we all know this, right? A plus b, a minus b square. Yeah, that's why. So expanding it out, so bringing this over to that, you can get sort of something like a b minus square root c over b minus square root c square, which cancels out the square root term. Yeah, therefore at the bottom there's no sort of like a square root term, so it becomes a over b square minus c bracket b minus square root c. All good. That's rationalization in a nutshell. You can memorize this if you want, it's fine. Exams, but yeah. But I suggest not. I suggest deriving it on your own. Pretty fun sometimes. Now let me sort of add an image. This is from Anglican High. Yeah. I don't know whether it's copyright to take this, but I just want to share it because I think it's quite good questions. Yeah. So let's see. 2 plus. So this is a typical sort of like rationalization question where you're supposed to you see square root term at the bottom, but there's no square root term at the bottom here, and it's all just numbers. So like, let me use blue. I like blue. I don't know. Blue is nice, bruh. So like, let's do it step by step slowly. 7 square minus 18. 3 minus square root 7. Now we know that. So first of all, I would suggest just expand this out first. It's quite yeah, because it makes it look a lot easier, you know. So we know that a square a plus b square equal to what? To your special equations a square plus 2ab plus b square, right? Right? If you want to prove this, you can just expand it out normally. But yeah, I digress. So this will be 2 square plus um 2 square root 7 plus square root 7 square. Now then we'll just plot this over here, minus 18 over 3 minus square root 7. Yeah, we don't touch this first until we finish with everything outside. So this will be, doing some simple math. 4 plus 7 is 11 plus 4 square root 7 minus 18 over 3 minus square over square root 7. Yeah. So you can do it two ways. You can bring this up by multiplying with the denominator, or you can rationalize it first. I suggest rationalizing it first because when you rationalize this first, it makes it look a lot easier because you're dealing with one plane only. There's no denominator, or at least no not rational denominator of sorts. So sort of like, so the way to do this is basically, yeah, multiply the, I guess, the sum of it instead of the negative. 18 3 minus 3 plus square root 7, yeah, over, well, now 3 plus minus square root 7, 3 plus square root 7. So yeah, you see these are equal, right? Because this can just cancel out, but we're not going to cancel it out, we're going to expand it out. So equal to 11 plus 4 square root 7 minus uh, 18 3 plus square root 7 over 3 square minus square root 7 square. All this can lead to, let me erase this over here. Yeah, so this one can just do it as 11, yes, 11 plus 4 square root 7 minus 18 over 2, which is, well, 9, 3 plus square root 7. Yeah, and now you can see it's quite fairly obvious, right? You see that these are two integers, so you can minus them equally. So 11 minus 9 times 3. And now you see that these are the surds part. So plus 4 minus 9 square root 7. You can do it in another color so it doesn't look so messy. Yeah, so the final answer would be something like minus 5 square root 7, right? Yeah, that's simple. I can understand like some basic rationalization, right? Not you can watch this video again. I don't mind. Yeah. Let's solve question 2A, I guess. So this looks complicated. So usually for a complicated indices question, you just want to break it down. I'll show you what I mean soon. Well, you see this, right? I'm just writing out the expression. Now you can, most of the time when you see like 25 or like 10, right? Not prime numbers, you want to split them up into their prime. So like 10 equal to 2 times 5, for instance. Right? So I would probably split this up into 5 square p times, well, 2 times 5, 1 plus p over, well, the rest of it is the same because these are all prime numbers, so we don't really care about this. This is usually the start of what I do in the exam. Yeah. Go to, well, this one is using the second law. You can know that 2 times p 2p times 2 times 5p, so 1 plus p, so you can expand this out sort of, so 2 1 plus p times 5. Oh yeah, times 5 1 plus p. Quite simple. Over I don't know, man, I like the colors, but 2p minus 1 times 5 times 2 3p, right? So yeah, okay, quite simple. And then now what you want to do would be to split this up. So you see this 2, so I'll bring the 2 to one side, over 2p minus 1. Now because this is multiple sides, I can sort of like extract this as a whole and put it like 5, right? Because it's all multiplying, so it's just multiplying the numerator and denominator. But yeah, fairly simple, right? Still following? I'll erase this part on top. Yeah. So then I would probably so we'll simplify this first. Remember the law, am divided by an, right? So it's 2 1 plus p minus, over here, p minus 1. Yeah, because now multiply by, now this is an addition, remember, 5 2p plus 1 plus p, and this is a negative, it's a minus 2 plus 3p. Yeah, and now you can probably see how you simplify everything. The rest of it is more like algebra, so I think you'll get something like 2 squared and negative 1. This is not yet simplified enough. I would say the most simplified form is 4 times 1 over 5, which is, well, 4 over 5. Simple, yeah. Simple steps. Yeah. I think, okay, for the next part, it's a little tricky, but we can do it. It's fine. Yeah. B. So let's see. Show that 8n plus 8n plus 2 plus 8n plus 4 equal to let's say 24a, where a is an integer, right? Right? Yeah, this is what it means to be divisible. So we need to prove that a is an integer very simply. I will sort of do it something like a. Yeah, I'll just expand it out first. So this one I can't really do anything about it. But for this one, for this term, I can do something like I can pull out the power 2, right? By the multiplying law. Same with the 4. So equal to 8 power 4. Yeah, so yeah. So you're left with this, then you see that this is 3 common terms, so what you can do would be probably factorizing it out, and you're left with 1 plus, let me write it in blue, plus 8 squared plus 8 power 4. Now they say that n is a positive. Oh well, I mean, wait. On that note, wait a second. I'll simplify it even further, which is yeah. Now they say that what? N is a positive integer, and so by that it means n must be greater than or at least 1. So n minus 1 is 0, 8 power 0 equal to 1. So it's okay to minus 1, is what they're trying to tell us. So let's say I pull out an 8, right? Right? So I'll get 8. I'm pulling out an 8, right? Oh, what the heck? Yeah. I'll get something like, hold on. Yeah. 33288. Yeah. Which is, well, lo and behold, well, 8 n minus 1 bracket 33288 can be expressed as 8 n minus 1 bracket and divided by 24. It will be equal to 1387 times 24. And there we go. Because this will always be an integer no matter what. As you can tell, right? All you need to do is write out the statement. But yeah, most of it is done. Lastly, let's look at part C, right? C, 2 minus 2a equal to 2a plus 3 minus 4a plus 1. Right, then we need to solve for a, right? I would suggest, first of all, this 4. You can convert it to a 2. Yeah, so remember the same thing as the prime, so let's do square, which is equal to 2a plus 3 minus 2a plus 1. Yeah. And now look at it, right? Let me solve. Yeah, I think, yeah, so 2 minus a. Now you don't really know what to do. Well, understandable. 2 minus 2a, I would say that you can do the same trick as before, expanding it out. But we can't really do anything with this 2a. Hold on. I'll write it more like 2a square times, oh, this should be 2 by the way. This should be 2. I'll write it more like times 4. You can see why later, but think of it like, so overall you'll get something like 2 minus 2a equal to negative, oh, equal to 2a 2 power 3 minus 2a square 4, right? And now what I would do would be to bring it over to the other side. Just bring it over. So bring all of it over and write it in the order of their powers. So 2a squared times 4 minus 2a, well, minus minus 1 plus 2 power 3 2a plus 2, right, equal to 0. And this might look a little bit familiar, but if I were to sort of show it out, you can do this substitution trick. So let 2a equal to x, for instance, and it just becomes a quadratic equation. And minus, now this is 9, 9x plus 2 equals 0. And using your quadratic equation, so you can probably do something like minus 481 minus 4 for 1632, I think, over 2 power times 4, which is 8, and it equals to, well, yeah, whatever, some term which you then can find, well, a itself using another thing called logarithm. That's about it. Using logarithms, which is later on. Yeah. For square. Yeah. Oh, I guess the answer is we don't really need logarithms. We can do 2, right? Yeah. Uh, yeah. So I guess 1 over 4 or 2. So as you can tell, this is equal to, I guess. So implies that, I guess, 2 power a equal to, I'll rewrite 1 over 4 as 2 power negative 2 or 2 power 1. So a is either, well, a is either negative 2 or 1. You can tell why, right? Yeah. Thank you for watching. You've been great audience, and yeah, I hope to see you in the next video. Goodbye.